All right, thanks, Tim. Yeah, for those of you who don't really know me, this is the first webinar that I've done for WKO4. I'm one of the original developers of TrainingPeaks and also the WKO4 software. And what I was hoping to show everybody today is some of the basics of chart building that you really need to know in order to get into some advanced chart techniques, and then move on from there into the actual, building of some advanced charts. So I'm going to kind of mix together a little bit of theory, and then switch back and forth into some practical applications of the theory. So I'm hoping that I'm not going to lose anyone on the theory part, so I'm going to try and keep it as interesting as possible. Please bear with me, because it's stuff that you need to know in order to really use everything the way that it should be used. Okay. So this is one of our standard slides that we put up. Everybody in the webinar is on mute. You can type questions into the box as we go. I'll try and keep an eye on it and answer things as I can. We also have a WKO4 Power Users Group. Hopefully everybody on the webinar knows about it and is already signed up. If you haven't, maybe throw a question up into the question box, and we can explain how to sign up for the users group. But that's a great place to ask some in-depth questions, get answers from not just Tim and I, but the entire community, and get different perspectives on how people use the software. So the first question, I guess, to start at the very beginning is, why build charts? We have a huge library of charts that are already built, and to be honest, it should cover a lot of, if not almost all of everything that you really need in order to successfully use WKO4. So, why do you need to build charts? And the answer is we're finding that everybody wants things to work their way. And if you put, a dozen people in a room and ask them how something should work, it seems like you get almost a dozen slightly different answers. So our answer to this is, well, just customize it and make it the way you want it. The other thing is, in the very beginning, when we were going through all of the different ideas for what we were going to include in WKO4, one of the ideas was, a way, an API or something to allow people to extend WKO4 and write programs, add-ins to extend WKO4. And the problem with that is not everybody wants to be a programmer. It takes a certain amount of effort to learn and so forth. So we came up with this idea of extending it by allowing you to create your own charts and using what we call expressions, which are really just mathematical formulas. It's not programming, because there's missing some important concepts in programming. Really what it is just math. Okay. And lastly, what we're finding as we go along, people have just a lot of ad hoc questions where they just want to know an answer to something, like a one-off, and creating your own chart to answer those one-off questions is a really great way to gain some insights. Just as an example, one time Tim said, you coast a lot. So I said, well, I just wonder actually how much I do coast. So I created a chart. It hung around for a day or two. I learned something about the way I ride, and then I deleted it because I didn't really need it anymore. It was just kind of a passing interest. Okay. So how do we get started? One of the things that I want to point out, when you go to start working on a chart, you really need to be able to clearly define what it is you're trying to accomplish. I've helped a bunch of people build charts, and one problem that I just can't help people with is if they don't know what it is they want to do. That happens sometimes, and it's not a WKO4 problem really, because you need to know to start with what it is you're trying to do. So it helps to have some idea of what your intent is, what you want to create, and be able to articulate that. Especially then, that would allow you to, if you have questions, post the question. It's very specific on the WKO4 power users group. You also don't want to just reinvent the wheel. A lot of things have already been done, so you can search the chart library for a starting point. I can quickly flip to my WKO4. So hopefully you can see my WKO4 screen here, but this button here that says chart library accesses an area of the software that's updated online. So you're seeing basically a contribution of charts from the whole community. So if you want to find a chart by a distance, just go to chart library and type distance, and see if the chart that you want already exists. You can type MMP, PMC, whatever you think, maybe performance. That's interesting. I thought Tim, we had a bunch of charts that are tagged PMC, but I must be wrong about that. When you switch over to My Charts, then you're actually looking at the charts that are loaded on your computer and ready for use. Okay, so always go to chart library and see if the work has already been done. Even if the work hasn't already been done, if you find a chart that's already similar, it's much easier to take a chart that already exists and change it to the way you want than to start from scratch. A lot of times when you start from scratch and see that blank canvas, people tend to freeze. But if you have a good starting point, it seems just a lot easier to customize something someone's already done. So to kick it off, I'll show this in a minute, but create a custom chart using the chart button in the menu item. Create a custom chart. There's some expressions already written in a button that's not very obvious, but if you press or click on the expressions word on the chart configuration screen, it'll pop up a box with some pre-built expressions. It's pretty basic right now, and we're going to be adding more as time goes on, but instead of having to remember everything and type it out, you might be able just to pick it right off of a menu. Okay, and we also have a really nice expression reference guide that is installed on your computer when you install the software, and that has a lot of detail. It's a work in progress. There's some things that aren't filled in, but that's a great place to go and look to find information about specifically how something works, and also there's a lot of examples in there. Okay. Also make sure to review these slides and as I look at existing charts, and everything that I'm using in this webinar can be found at that URL. So there's a beta build out there that does some things that the currently released build doesn't do. There's some example WKO4 chart files out there, and also these slides. So I'll give everyone just a second to take a look at that if you wanted to jot that down. I can also paste it into the chat box too. Actually, Tim, if you don't mind, maybe if you're listening in,
it's already there.
I sent you that.
Yeah,
if you don't mind pasting that into the chat box, because I don't think I can copy it off of here while the...
Yep, I just pasted it into the question box, and I'll paste it in the chart box or the chat box right now for everyone.
Okay, so then you might be able to just copy it out of there and into your browser. So I know everybody likes to get the slides or the chart file, so I just preemptively just publish them at that link. Okay. Okay, so one of the things that is really important, even some kind of advanced chart builders don't seem to understand yet, is that there's really two halves to charting. One half is getting the data, doing the calculations, and then the second half is formatting it. So, they're very distinct actually. So what a lot of people do is they'll change the formatting and sort of expect it to change the values or change the calculations. But really, when you're formatting the data, you're just changing the way that it looks. You're just changing the labels, the colors. It's not actually calculating anything differently. All the calculations are done in this first step in creating the expressions themselves. So there's two things that you need to know. You need to know how to write expressions. And you can start out, very simply and move, to complex. And then also, there's some tricks that I can show you to how to format the data once you have, the information. Different ways that you can format it for displaying on the screen. Okay, so I know the title of the webinar is Advanced Chart Building, but I wanted to start, at the simplest level first and build up there. I'll go as quickly as I can to avoid wasting time, but I'm finding that everybody learns a little something that they might have missed along the way that's kind of holding them back. So it's a good idea to start here. So really what expressions are is just numbers and operators. At least at the very most simple level. So you can take numbers, do math on them, compare them, and as you can see in my example down below, if you use parentheses, you can change the order in which things are evaluated. So 7 times 4 is 28 plus 3 is 31, which is different than 7 times 4 plus 3, which is 49. So parentheses in this context help you change the order in which things are evaluated. The first 3 there are just math, and the third one is a comparison. So it's going to give you a 1 or true if 7 is greater than 3 and 2 is not equal to 1. So that's true. So it'll give you a 1. Otherwise, it's false. If you said 2 equal 1, that would be false. So that would give you a 0. Okay. So I can do a really super quick chart. Actually, I'll create a report just to give an example. Pretty much this is the simplest expression that I could think of is 1. Using some of the examples, I don't remember the exact number I used, but you could say 7 plus 2 times 3. And it does the math for you. You put parentheses in. Basically, it's just like a calculator. Change the grouping and get different numbers. Okay. We have a power like 2 squared is 4, and so on. If I also give you an example of a comparison, 5 is greater than 4. But 5 is not greater than 9, so that gives 0. Okay, so far what we have is a calculator that calculates numbers and does comparisons. Okay, so moving forward, I showed you numbers. You also have dates and durations and strings, besides the numbers that you can use. So one thing, by the way, I don't know if anyone's noticed that I reformatted the screen a little bit in this build so the box is a little bigger and it colors things. So you'll notice that numbers are colored orange. actually all constants, meaning things that don't change. They're not variables. They 20 minutes doesn't change, 9 doesn't change. They're all colored warm colors, meaning like red or orange or yellow, to help you visually see the the expression a little better. But if I can also, in this expression box, I can type in a date, like today's date is 11/15/2016. It immediately recognizes that as a date, colors it yellow, and you can see that up on the screen. I can type in 20 minutes, and it recognizes that as a time. You can do math on time as well. You can add 60 seconds, and that up there in the corner shows 21 minutes. Okay. Let's see. I'll go into strings a little bit more later on when it's there's something more relevant. So the next thing that you're missing is, besides just the simple math operators, you can call functions, and the functions, what they do is they just do some operation on the data, taking one or more pieces of data as input and give you an output. So if I went back to the other screen and use this first math function, I could say, what is the square root of 64? I think that's 8, right? That's 8. So here's a good time to explain a couple things, because I'm going to stop here and show. You notice this shows as 8 seconds, not as just 8. And that's because this box had the y-axis label set to hours, minutes, and seconds. So what this is doing is it's formatting the result as 8 seconds, but it's not doing a conversion on it. It's not really converting. So if I set that to blank, it goes back to 8. One of the examples that I like to give people so that they understand, it's not really units that you're typing here. It's a label for the column. So I could put RPM here, and it becomes 8 RPM. If you can see my cursor, I'll highlight that. It's 8 RPM. If I change RPMs to hippos, it didn't do any conversion. It's just a name. It does add some formatting, like I said. If I change it to a date, it formats it as a date, which is 8 is 9 days into 1901, so that's why you see a funky date there. If I put hours, minutes, and seconds, it reformats it, but it doesn't ever do a conversion. Okay, so that's a really key piece of information. While we're here, I might as well show the rounding box. If I change that to a fraction, I can change the number of places that it's rounded to. Okay. So I have a bunch of different examples. These are things that I don't think I should spend time on here. You could easily look them up in the expression guide, what they do. The expression guide's got things organized between math functions and rounding, statistical, what I call selection, meaning is picking things out of a list, and reshaping, meaning changing the list. These are all things that are in the guide. What my point here really was to show you that the syntax for functions is the function name, open paren, and then one or more pieces of data in a closed paren. Okay. So as far as syntax goes, we're very close to everything there is to know really about syntax. The rest of it is specifics about what the parameters are. One last thing I really want to show you here before I move on to ordered pairs is that if I change this to a chart, as you saw it in report form, if I change it to a chart, if I type in a number, you can see over here it just graphs a horizontal line. So a number by itself is just a horizontal line when you chart it. That's because really what you're doing here is specifying a y value. A y value meaning if you had a like a algebraic graphing calculator, what you're really saying is, you know, y equals 3, or whatever the number is that you have here. So you get a a horizontal line. What I'm talking about here with ordered pairs is, now I'd like to move into the idea of points, because in order to be able to create charts, you have to be able to put points on the screen in addition to lines. So like when you're talking about power and so forth, those are each individual data points. So in WKO4, everything is graphed on a Cartesian coordinate system using points. So if I was to use 3, 5 as an example and change this to 3, 5, it's going to actually put a point on the screen. I have to change my symbol style to circle, but there's a point at 3 over and 5 up on that y-axis. So I could put another point on there. I could put a point, at 0, 0, and make that a circle as well, and turn off the line there. And it should draw a. Oops, I'm sorry, I mistyped there. It should draw, a dot at 0, 0, and I have another dot, up there at 3, 5. Okay. So in the process of making my typo, I did show this idea that if you omit the x or the y, you get a horizontal line. So if I don't have an x and I just specify a y, I get a horizontal line. And if I do the same, except I specify an x value in xy format, but don't specify a y, I'll get a vertical line like this. Okay. By the way, I also accidentally hit this. This is the button I was telling you about where you can pick some pre-built expressions, and we're in the process of expanding this. But it's something, just the idea is to make it easier for you to enter expressions later on. Okay, so that's pretty much what I wanted to say about ordered pairs, or just individual data points. So the thing is, you'll notice that I had to create a separate data series for each point that I drew. So really what we want is the ability to draw multiple points without having to create multiple data series. So a set is really just a list of numbers. So if I go back to the WKO4, and I use this format of an open brace and then a comma-separated list of numbers, like I could put 1, 2, 3, I should get 3 lines. 1, 2, 3. I can also make those data points. I can put a point at 0, 0, and then another one at 3, 4, and lastly another point at 7, 8. Okay, and make that circle. And I'll turn off the line that's connecting them for a moment. So those are my 3 points that I just entered there, there, and there. Okay. So you can also do this. This is going to start to actually become really useful shortly, and you can do some really cool things with it. So hopefully you're still with me on this. You can also, besides having numbers, you can also have dates. So I have 2 dates. I also showed you you can have lists of points. There's some shortcut ways to specify a list. So if you use the colon character, it's in the format of from and to. So like 1:6 is just the numbers between 1 and 6, and you can skip numbers by adding a third one. So here in this example, it's going to skip by 2s. Go from 1 through 6, skipping by 2s. And then there's another form that uses a semicolon that repeats, repeats the numbers, that many times. And then you can mix them together. So I can start with 3, and then all the numbers 10 through 13, and then 21. Okay, so everybody has this slide, so you can always refer back to it. I know I'm probably going through it pretty quickly, so it's something that, it's okay if you don't get it right now, but as we get to some of the other examples a little bit down the road, you can always refer back to this slide to help remember how this is used. Okay, so now we get to variables, and this is really where you can actually start doing something real in WKO4. The first sets of variables I wanted to talk about are data channels, and those are sets of ordered pairs that come from your bike computer. Okay, they're already in XY form, so when talking about power, that's already in the form of elapsed time on the x-axis and power on the y-axis. Okay, same thing, heart rate is already a list of elapsed time on the x-axis and heart rate on the y-axis. So what happens then if I go back to my charts, let me delete some of these. Okay, and I type in power, I get on my x-axis elapsed time and power on my y-axis. If I flip this to a report, it might take a second to fill that in, but you can actually see these are the ordered pairs. So this first column is my x value, and the second column is the y value, and then it's a big long list that goes on and on for a couple hours. Okay, so there are some sport-specific data channels. If you prefix the data channel with the sport name, like bike, run, or swim, then it'll only pick up the data for if the sport type for that workout matches. So one of the things that really seems to mess things up is now that we have running power, we're finding you can't mix running power and bike power, so we've spent a lot of time reworking a lot of our charts to have bike-only charts that use bike power and run power-only charts that use run power. But you can do the same thing with heart rate or speed as well in your data if you want to target a specific sport type without having to resort to more complicated if functions and so forth. You just prefix the channel name with the sport type. Okay. And lastly, there's a couple important variations of the data. Elapsed time is just the cumulative time so far in the workout. So you can see here the elapsed time is increasing as we go up. It's 30 minutes here, 50 minutes here. Same thing with distances. Distance is ever increasing as you go farther and farther. Something that you really need to know also is there's this concept of delta time and delta distance, which is the change in time for a particular record or the change in distance for a particular record. So there's two ways of looking at speed, right? Like you can use the speed channel, or you can use the change in distance over change in time is another way of calculating speed. So these days, the way that bike computers work, unfortunately, delta distance divided by delta time doesn't equal speed, because I'm finding that what happens is they do things to smooth and manipulate the speed channel I think to remove high frequency noise from GPS and so forth. But in a normal world of Newtonian physics, speed is the same thing as delta distance over delta time. Okay. So one of the questions that we get a lot is, I don't want to see just time on the x-axis. I want to see how does power relate to distance. So since the data comes in as elapsed time power, if you want to change it to distance and power, so you're comparing or graphing power over distance, I can show you that. So this is exactly equal to that, right? But if you want to see distance on the x-axis, now it shows miles down there. Okay, and because even if I change this to kilometers, it still shows 30. And again, if I change this to hippos, it doesn't convert to hippos. It still says 30. So what really, if you want to convert your data to metric, you can put metric in here. By the way, it would be metric automatically if your preferences in WKO4 were metric. You only need to do this if you want to switch to what's not your default. But you'll notice instead of 30 miles, it's like around 48 kilometers now. And it's switched your x-axis label for you automatically to kilometers. It does that whenever it can. Okay. But besides distance and time, what if you wanted to show the relationship of heart rate and power? You just put heart rate on the x, it's an XY format. So heart rate on the x, power on the y, and boom. So I'm going to turn the line style off and put dots, and now I have a scatter graph showing the relationship of heart rate and power. Okay. Another one that might be useful is temperature, showing how maybe temperature affects heart rate, or how the two are related. You get the general idea, I hope. Okay. There might be times when you want to flip the x and the y. So, for example, if I go back to power, I see, and I'm going to turn the symbols off and go back to a solid line. There. We see on the x-axis we have time, and the y-axis we have power in watts. You can flip the two using a function called yx, and that flips the whole thing 90 degrees and puts time on the y-axis and power on the x-axis. This particular example is not useful, but I'm just trying to show you the idea of the difference between the x and the y-axis in WKO4. Okay. So let's see, moving on to the next slide. Now that we can actually look at the data channels, the raw data channels that come from the from the bike computer, the next thing is good to do then is to start doing some type of analysis on it to learn some more. So I kind of skipped over some of the functions that we talked earlier, like you can say AVG to get average power, which is a line because it doesn't have an x value, it's just a single number. If we go back to report, on this ride my average power was 201 watts. Okay. You can use max to find out the maximum power. Minimum power is not very interesting. Some just gives you some giant uninteresting number or not useful number. Okay, but one of the things that we seem to like to do is to search for our bests. So if you say mean max, it finds let's say we want to find our best 20 minutes power. It's basically here telling us that our best was 233 watts. So in order to keep it so I don't have to keep flipping back and forth, you can use what I call an annotation. So I can say I just want to put that in the top left of the screen. I want to show that number. So like if you have something that's just a number, you can put that, and then I like to turn the line off so it just shows up. Okay, and then you can actually put power here. So okay, I should probably explain what happens here is that WKO4, when you have two different x-axes, it will put the two on two different charts. So what happens is that it'll happily overlap two different charts if they have different y-axes, but if the two different charts have different x-axes, it'll create a new chart. So the reason why that is, here as you see on the x-axis, it's watts on that data series, and on this data series, it's hours, minutes, and seconds. So to get them onto the same chart, I have to put hours, minutes, seconds, and then boom, they're on the same chart. So that's actually kind of a useful thing to be able to do. I can talk about that in a little bit, but that's a technique I use on a chart called Kevin's PMC chart that I use to separate out different types of data onto different plots, but on the same chart. So anyway, mean max, power, 20 minutes, you can easily change that to heart rate or some other data channel. So you can see my highest 20 minutes heart rate was 166 BPM. You can put speed, it's 22 miles per hour, so forth. Yeah. So going back, there's another form of mean max that doesn't have a duration, and it builds a curve. Everybody knows this as a mean maximal curve. So if I went back here and said, mean max power, again with that, I'm going to delete that. What am I doing wrong? I'm doing something wrong here. Oh, that was dumb. I had my line style turned off. It's funny, you can all laugh at me. I do it too. If you turn off the line and you don't have any symbols, then you don't get a chart. So you can use dots, or you can use lines, or both. But if you have everything turned off, then you'll have a blank chart. Okay, so you can create a mean max power chart. You can create a mean max speed charts, and so forth. I think everybody on this webinar probably has seen this before in one way or another. This idea has been around for a long time. Okay. So we can move to something a little bit more advanced here. Somebody asked recently a question on the power user group. How do I see the work that I've done at each point on my mean maximal power curve? So in order to show work, work is related to power in that you take power, watts times seconds, and divided by 1,000, to get kilojoules. So we know the expression for watts, is mean max, gives you your curve. But the problem is up until recently there was no way to get the number of seconds at each point in the curve, because the mean max curve, I'll show here, is formatted. I'm going to change that back to power. But it's formatted with watts on one axis and then the number of seconds on this axis. So in order to multiply this to get work, there was previously no way to get at the x-axis value, but now we have this function called xx, which will give you the x-axis value. So now I can multiply the y value times the x value, and this shows the amount of work that's done at every point on the on the mean max curve. Okay, so if I just went to like 20 minutes or so here, that's saying that I did 279 kilojoules of work. I forgot to divide it by 1,000, so it's coming out as 279,000. But you should know how to divide that by 1,000, so I'm not going to show that. Okay. So anyway, that's shows bests, and you know, maybe just really quickly to show the XX function one more time. If I have you know, power in a report, you can see I already showed you this, how the x-axis is duration and the y-axis is power. If I use the y-axis function, it flips them. And if I use x-axis, I get the x-axis value for both. Okay. So anyway, moving on from bests, the next thing that I wanted to talk about is time and levels. I think everybody's probably seen these first two forms, so I think I can skip over them. What really seems to come up is this question. It's like, well, you know, WKO4 doesn't support very many different types of training levels. So I wanted to show everybody, you know, you can create your own by taking numbers from somebody else's level or just inventing your own altogether. So if you use this bin function, you can bin your power or heart rate data into levels based on hard numbers. So let's say my levels are, you know, from 0 to 100, 100 to 200, 200 to 300, 300 to 500, and 500 and up. That shows how you can accomplish, you know, creating the time and custom levels. You can also create them based on a percentage of your set FTP. So if I take percentages in a set and multiply them by SFTP, so that's kind of why the understanding of how to type in a set, you know, of numbers is important. So what that's going to do is it's going to take SFTP and multiply it by 0.8, multiply it by 0.9, multiply it by 1, multiply it by 1.1, and use that. So as your SFTP changes, and you know, hopefully improving, it's going to put the you know, the power numbers in the bins that are appropriate to the SFTP as of the date of each workout. Okay. There's an example I have down here that shows how you can use the athlete range function. I have more on that later, but if you don't want to use SFTP, if you want to use your modeled FTP, instead of multiplying by SFTP, you can multiply by you know, the last 90 days or your, you know, modeled FTP based on the last 90 days using that expression. Okay. You know, this power duration curve functions. At this point, I hope everybody knows about, you know, the power duration curve and how you can model different parameters like FTP and FRC. So this top part here shouldn't be new. Something that might be new is understanding that it can also give you a error window for each of the parameters, because it actually can, within the model, it knows how much you know, variance there could be based on how well the curve fit your particular data. So we haven't been talking about this much on the power users group, but when WKO4 says, you know, your MFTP is 278 watts, you should use FTPE, and that might tell you it's, you know, I'll give you a number back like 7, and what that means is WKO4 knows that your MFTP is 278 watts plus or minus 7 watts. So the better curve fit that you have, meaning you have more data and, you know, more maximal efforts, and your mean max power, you know, is close to the PD curve line, that error will be, you know, very small. And if you're looking at only a date range with a couple of workouts and it's your MMP curve is really lumpy, you know, that error is going to increase. Yeah. There's a new function also that I created called linear interpolation that lets you pick data points off of a curve. So like if you take the PD curve, I can find out what is the power at 20 minutes. Okay, and if I use this y-axis to flip the x and y-axis, I can reverse that and say I want to find the duration where power is 300 watts. Okay, so that's something that I would encourage you to copy and paste, out of the slides when you get them, those expressions, and you can, use those to find out, what my modeled power is, at different durations. Okay. Conditions. This is a way of conditionally including data based on something, based on a Boolean condition. So you can say, like, if some condition is true, then use the true value, otherwise use the false value. So in the very beginning, we created this function called no0 that removes zeros from a channel, but you can also accomplish the same thing using if. So I can get my average cadence without zeros either using no0, or I can get it by saying, if cadence is greater than 0, then cadence, otherwise, nothing. And then those two will give you the same number. There's a kind of a cool thing that we started to do just to show you something, much more complicated example. We can create a power duration curve using a mean-max curve that's generated only when you exceed 2,000 kilojoules. So one of the things that separates superhero riders from us mere mortals is their ability to ride hard after they've done a certain amount of work. So this is something that we've been playing with lately, is just looking at people's power duration curves or mean-max curves after they've put in a certain amount of work. So this example is 2,000 kilojoules. You can change that to 3,000 or 1,000 or or whatever number you want in your own chart. Okay. Next there's a really handy expression called workout range. Until recently, when you would click on different ranges in the right-hand Explorer, it filters data out so that the chart only gets the data from that range. So like if you pick lap 1 or lap 2, you're only seeing the chart using the data from lap 1 or lap 2 or your best 5 minutes. What workout range does is it lets you totally defeat that feature, which I sort of would kind of discourage, because the whole point is being able to see what happens when I look at individual ranges, or different ranges, or compare ranges with the control click feature. But there are times that it makes sense to look at only part of a rod. Like let's say you have a metric where you want to take the second half of your workout and divide it by the first half of the workout. This first example shows you how to do that. It starts at 0 and ends at duration over 2, so this is going to look at the first half of your workout and give you the average power, regardless of whatever you have clicked in the right-hand Explorer. Okay. Athlete range lets you get data from the athlete level. So one of the challenges that we've had is at the workout level, we weren't able to actually get your modeled power, because your modeled power depends on data outside of the current workout that you're looking at. In this example here, I'm using the last 90 days. So when you're actually looking at a workout, you don't really have access to other workouts, let alone the last 90 days of other workouts. So what this athlete range function does is it lets you sort of reach upward into the athlete level to grab data from other workouts. So what this expression does is it takes your average power and divides it by your modeled FTP using the date of the current workout in 90 days prior to that. Okay. One of the a fun trick I like to do is when I'm looking at a workout, I like to put the mean maximal power for that particular workout on the screen, and then also show a mean maximal power curve for the 90 days prior to today's workout, but not including today's workout, so I can kind of see like if this workout has new bests, or how this workout compares to what I've been doing in the last 90 days. So you can put this expression alongside in one data series, and then mean max power in another data series to see how this workout compares. It's funny. Update. What I really wanted to leave everybody with is some pretty cool new ideas. So I created a few charts using the information earlier here that I talked about in the webinar, how to create some charts. So the expressions are here, and then my output is here. But if for some reason you don't like the way that I'm calculating the numbers on the athlete details or the workout details for the way that the levels work, or you have your own proprietary system of computing training levels that aren't built into the software, or you did some testing of your own and have your own ideas. What I did is I created a chart that gives you all the same information as what the workout details chart gives you. So in the same chart, when I'm viewing a workout, I have a level number, I have my own proprietary level name. I give everybody on the webinar permission to use this if somehow you find my this new system of training levels useful. The from watts to 2 watts, percentage of, I'm using set FTP, you can see up here, dividing by set FTP. And besides the levels, I'm also showing for this particular workout the time in the level, and also the percentage of time in the level. So the chart is available to you in the link that I gave earlier if you wanted to play with that. We're running out of time, so I can't go into how this works in this webinar, but I can see maybe possibly adding a webinar again, Advanced Chart Building 2, to go into these things a little deeper. If everybody wants to go deeper into these things. Okay. Another thing that I built is this idea of a run splits report. In the materials, I have a run splits report that shows you your run splits every 5K. So this is my, actually it's not mine, it's somebody else's, because I'm not much of a runner, but it's my, or his, average pace for the first 5K, average pace for the next 5K, and so forth. So what this expression here does, this sort of long ugly thing, is it dices up your workout into 5K chunks. I have another one that I don't have a screenshot here, but it's in the charts, that does the same thing for bike rides, but dices up into by time into 20-minute segments. So this is something that we can explore more in another webinar, or you can ask questions on the power users group. Now you can take any particular range that you might click in the right-hand explorer and dice it up into smaller pieces. You can divide it up into halves, quarters, thirds, fifths, or you can divide it up by time, or you can divide it up by distance. Okay. And then a couple other quick things I wanted to explain is, note that you can't use the time notation inside of braces, because inside of braces the colon means from and to. So in this case I have a couple of numbers, a date, and then a time. it's not going to let you do that. So if you wanted to have 20 minutes, for example, you're going to have to put 1200 inside of braces like this, not be able to say, 0:20:00. And then one last thing, I shot myself in the foot pretty badly one day because I couldn't figure out why when I sorted data or used the reverse data function, the graph not changed. Then I realized that it makes a difference in the reports because sort and reverse change the order something appears in the reports, but when you plot it in two-dimensional space, all the points end up in the same place. You're just changing the order in which they're plotted. So hopefully that makes sense to you, but when you use a chart, sort and reverse actually won't change the appearance of the chart. It only changes the reports. Okay. So I think I've used up much of our time here. I hope everybody found things useful. If there's, I'm sorry. Go ahead, Tim.
Yeah, no, Kev. I mean, one thing with time. Most of the people on this webinar come to my webinars, and I never even get close, as you know. So the reality is, if we're going to go into Q&A, I know there's a lot of questions. Anybody who can't stay on, totally understood. People who want to spend some time asking questions about specific charts and stuff like that, why don't you do so now? Now's a great time to get some round of answers. We're going to have one of the things that I've been considering doing, and just based on the questions I'm seeing, but more to the fact I got 5 or 6 emails while this is going on from people on here. They really want to do more of a chart building hangout, and maybe that's something we can do in December. We've got some travel coming up, and then Thanksgiving holidays, but maybe starting in the first week of December, we can start putting a date on the calendar to do like a Google Hangout or something like that, and then just have people come in who are struggling to build some charts or just want some direction. So I'd like to say, Kev, if you could take as many questions and as we can now, and people want to stay on, that's great. Can you go back 1 or 2 slides?
Certainly.
Like there, right? So you guys do realize, everybody in this webinar, he does this to me every day. Like, he explains that like this is simple, and you realize he does that in his head. So yeah, you guys aren't the only one. I got like 4 or 5 emails like, wow, that's a lot of stuff. Yeah, it is. But these are great ways to learn. It's hard, when you get this complex, and that's what the Facebook group is. It's not that complex. It's very patternistic. It just takes time of doing it. So why don't we let Kevin start? And Kev, if you want, I could ask you the questions right out of the group, and then you could just answer them. Really great if you could show it in WKO4.
Okay.
So let's go back to the top. I'll just read them to you. You just get your WKO4 up on the screen, and let's see if you can answer it or walk us through. I did hand out the presentation, you guys. I sent everybody the link in questions in chat. It's in that Dropbox. You also notice Kevin's build does something unique. It was doing all these colors and stuff like that. In that Dropbox, Kevin gave you an advanced build that's not public that will do all the things he's doing. You can download it and install it as being part of the group and get a little advanced look at the new chart building and all the great expressions he built in there. So Kevin, question number 1, can you build a chart with the time of day as the x-axis?
Okay, so yeah, so that's I think maybe what you're referring to there is looking at the athlete level. I've been sort of building from the ground up, starting at the workout level, and there's just so much material that I didn't really even get up to the athlete level. So once you get up to the athlete level, then you start looking at things, by date, which in WKO4 date is really date and time. That you're starting to access like the date and time of the workout and putting the the date on the x-axis. So far what I've shown really is all at the workout level. And that's why I was thinking that we could do a whole nother one of these, then moving up through the workout level and all the different things you can do there. So I don't know if that, I mean, it doesn't really, answer the question exactly. I mean, like, yes, you can put, graph things by, time and date on the x-axis, but that's like, like a whole nother, 60 minutes of me explaining, a bunch of new things that you can do.
Gotcha. All right, so why don't we just say, Craig, if you could post that one in the Facebook group, we'll see if we can't get to it and start answering it there. This way everybody learns at the same time. So here's one you could probably do. So Dave asks, so how to insert horizontal lines for workouts with several wattage targets. So Dave, I'm kind of assuming you mean you want a horizontal line at 300 watts. Hopefully that's, I think I understand. So yeah, let's look at a power-based workout. Yeah, that's what Dave is asking. That's an easy one. Even I could do that one.
Yeah, but there's a cool way to do it.
See, I knew he was going to say that. Because we do this all day long.
So, okay. So, the way that I showed is you can put them all in one data series. Now, it depends on what you want them to be. I can put one, let's say, like low is 200 watts, medium is 300 watts, and high is 400 watts. So now I need to have the same x-axis for them to be on the same graph. So there, I can just put numbers in there using one data series. But those are hard numbers, right?
Kevin, did you use a bracket or a parenthesis?
Those are brackets. So brackets are for sets.
Okay, just remember that, everybody. That's the trick I see people stumble on all the time. Brackets are for sets.
I don't know if everyone noticed. It's probably not so amazing here, but you notice like when I move inside there, it puts a little underline under the brackets. That's to help you find the match. So it's like if I want to know what the match is for this bracket, I put the cursor just before it and it shows me that the match is over there. So that's really helpful when you have like a really long, I'll go back to this. If you have this, I want to make sure that the close paren for the workout range, matches the very last one. You can put the cursor there and it'll underline the very last one, and that helps you, match. So besides the colors, it does the matching of parentheses and brackets. But Dave, I was going to say, you could also, by the way, do something kind of cool like saying, average power times, how about 0.91 and 1.1. So now I have three, what did I do wrong? And again, it has to be hours, minutes, and seconds. So now I have three lines. This bottom one is at 90% of my average power. The middle one is my average power, and the top one is my, 10% more than my average power. So, there's lots of ways you can use that feature to put horizontal lines. It just depends on what you're, I always tell people it depends on, the answer depends on the question you're asking.
Correct. Well, that's a good start. I think you gave Dave plenty of stuff to go on. Let's move on to the next one. This next question is a good one. Using conditions, can you use an if/then statement? For example, if average, no zero, cadence, show color as red, may be valuable for report format, highlighting an exception, which typically in Excel is known as conditional formatting. I'm adding the Excel part. So.
All right, so, right now our report generator doesn't do colors, though that's a really cool idea. A couple people have asked for that recently. As things start to grow, people come up with ideas for things that like we never really imagined when we started that we would get this complicated and this robust. So we can't color the reports, but that's something we could do someday. But we can color the graph here. So if I wanted to put cadence up there, let me kill power so that doesn't confuse. Let's say that I really want to know when my cadence goes. I'm just going to have to pick a number here. This was a trainer workout, so my cadence was pretty steady.
Yeah, you might
throughout.
use power. You might use power for the example you're thinking of. It might be better for you.
But I can say if cadence, greater than 95 cadence. Okay. So basically it's going to use cadence for any number greater than 95. So nothing happened, but it's because the green line actually is being drawn first. So let's move this up. So now there's like pink tips here. So this is really, over 95, and this is just to label them nicely, cadence. So that is another way I think also, by the way, if I understand the question, you can do it the way that Dave asked and put grid lines, or instead of a grid line, you could actually color, the numbers differently. So over 95, let's say, we'll make that red. Where's there's the WKO4 colors. So it makes all the instances where the power goes over,
Hey, Cap,
95.
What happens if you change the 95 cadence to 90?
You get more red.
Now change it to 85.
By the way, you'll notice that some of the lines are it's using the next point to do the color. You know what I'm saying? So like that point up here is red, but then as it goes down to draw this point, the whole line is green. If you're wondering why, this here's not red, it's because this point here is red. Like if I drew, a dot there, that point would be red. But then when it goes to draw this green dot down here, it draws a green line.
Yeah. Cool. That's an excellent example. So back to your PowerPoint on your pace slide. Kyle wants to know on the best slide, what does the prefix 60 do to the data? I think he means the peak one, where he's talking about pace. Yeah, there.
Oh, yeah. So, this is a really simple question that can get complicated to answer. Speed is normally a change in distance over a change in time, like 60 miles per hour, 55 miles per hour. Runners like to use pace, which is how many minutes. They flip it upside down, say how many minutes per mile. So to flip it upside down, you have to take the reciprocal of speed, or say 1 divided by speed, but then you multiply it by 60 to change from hours to minutes. So if you use 60 divided by mean max speed, that gives you your mean maximal pace. So the reason why I say it's complicated is because a lot of people say, then why didn't you just create a channel called pace? Which what we do is we find out that that works okay until you start doing averages, because if you do an average of 60 divided by speed is different than 60 divided by the average of speed. If you want to ask that on the power users group, I can show mathematically why that is, but you'll get 2 different answers. And what was happening to me is people would say, well, I'm using average pace, and I'm getting a number that's wrong. So what I did is I just removed that feature altogether, because really what you want to do is calculate everything as speed first, and then take 60 divided by whatever that is last to convert it to pace.
Yep. And that's the one that we get a decent amount of time, and it's just hard to understand that it's not as clean as everybody wants it to be. That is a great question to post and get answered in the Facebook group. I think people want to know.
I can go into a much deeper.
Yeah. All right, next question, Kev. I'm going to reverse Dean's 2 questions. What does the best run pace after 1,000 kilojoules of bike work look like? And then his previous question is any more thoughts on 2 different sport interactions?
Okay, so that's an issue with one of the things that you have to do is somehow decide how we're going to handle multiple sport types. So one way that we've traditionally done it is just create two different files. The problem with that is once they're in two different files, then you can't analyze one based on the analysis of the other, right? So the answer then becomes, well, we have to put the run and the bike in the same file, which isn't really hard. You just record your bike and you get off the bike and you start running, and unless you're using a fancy triathlon watch that changes sport types and does transitions for you, that should work. So what I was thinking along the lines of doing that, when you get off the bike, you're going to lose something, like meaning you're going to lose power, which not always, because now we have running power, but you might lose cadence. You're going to lose a data channel. So what we can do is start to assume that within a file you transition from one sport type to another when some sensor disappears, like your cadence sensor disappears. So I haven't got this worked out completely yet, but how earlier I showed the example of doing a mean max chart after you accumulated 2,000 kilojoules. I was thinking about building it the same way, saying after you stop accumulating cadence, as when cadence starts to turn, or disappears, then then build your mean max or your PD curve or whatever you want to do, after that. So where would that be in the here? This one at the bottom. This isn't the answer, but this is basically the general idea of what I want to do is to use the if, but instead of comparing it to a certain amount of work over 2,000, they're saying like, if cadence or power is missing for a certain amount of time, then feed that into the mean max or PD curve.
Yeah, so that's a future thing to be looked at. Obviously, continuing to move as fast as we can in these things, but it really is something as we get more capable of dealing with the way people are putting data together. It certainly is on the horizon.
Yeah, I'm trying to find a way to do it with what we've got. So I think that there might be a way. I haven't gotten there yet.
Yeah, correct. And it's funny. It also has a problem is you see that data compiled in different ways. A combination of the device merging other things too, which also can be challenging. Okay, that's it from the technical questions. I'll take a shot at the last one that was hanging in there. What's coming next for WKO4? Yeah, we have a lot going on. All you have to do is follow Andy. Yeah, it's hard to imagine.
My list is of future stuff.
Yeah.
Is so long. It's a matter of like how do we sort out, the good bits that give the most bang for the buck, because the list is so huge.
Yeah, we certainly opened up a sort of Pandora's box, right? And if you saw the feedback that we can do so many things, you sit here and you think about like all the stuff that's been open, and so many people want more. And part of it is we need to make sure we're digesting what we have. So we are doing, as most of you from this group know, we have an innovations conference going on this upcoming weekend. We're going to be announcing some new things at that conference. Andy's kind of teased them out already because he can't help himself. But we will be announcing some on the running side. We are going to be looking at the release of a new way of looking at power. That's, to me, the absolute best way to do it. Andy posted that today. By the way, Dean, Andy posted that today. I owed you that email response. And he showed his background and what he's going to present for what he's calling internal power, which takes into account running efficiency by picking up oscillation, lateral movement, things like that, which is actually, if you know why running with power is so difficult to nail down, is a really, really smart way to look at it. So he's going to go deeper. We're going to release that. If Andy and I can pin Kevin down for a little bit tomorrow, we should be able to actually put the charts out for attendees to be part of the beta group, and then that will probably trickle out a couple of weeks later. We do have some new science on some new stuff coming to help give you insights into training intensities, load, and actually training in time, intensity, and load. We are going to release the same way, only the attendees will get it, but it will trickle out once vetted a little deeper. We are releasing a relationship model to the power duration model that will show points of exertion on the model, and what points have the greatest impact. That model will give us, when mixed with the power duration model, will give us optimized intervals, and will give all coaches insights into what the best, not perfect, be really careful what we're saying here, because there is no perfect when you're talking about human physiology and dose and response and adaptation and blah, 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 but an optimized approach towards interval, time, intensity, and load. To me, is very exciting in how it works, because it finally takes these very broad training levels or training zones, whether you're using COG and Classic and COG and I levels, which are actually pretty broad. They're broad because they were always meant to be a description. When Andy wrote them and started the whole process of training levels, he wanted people not to prescribe using them. He wanted you to describe the work you did using them. But then coaches, because we didn't have a better system, latched onto that as the prescription method. Do a work, do 4 times 5 minutes in your VO2 max zone, right? He never meant them to be that way. And to be honest with you, most advanced coaches don't prescribe that way. Once you get to a certain point, you realize you have to be more specific, more based on history, more based on actual performance, everything else. So the training levels are always meant to be description. The new system is a system of prescription. Recommended prescriptions, optimized prescription, which is for a coach and for athletes, but particularly, for both. For coaching, if you really think about it, is something that's going to be pretty cool for you guys. The third thing that Andy's been showing is we are going to show a longer-term evolution towards adaptation scoring. I mean, there's no duck in it. We're only going to, it'll kind of be out there in the public in 3 days. And that really is a shift. Right now, training TSS is a training stress score. Stress is the external load. Strain is what your body goes under, and the end result is adaptation. Originally wrote the model, when we presented all the model data years ago, and some other people have copied that and made their own exertion models, but they don't work. There's a flaw, in my opinion. Sorry, my opinion, but there's flaws in it, and that's why we didn't rush to do it. We need to get everything right. But we're going to skip right over the idea of stress and strain and go right to adaptation, which will be the magic, because that's prescriptive analytics. And he's going to demo that. I wouldn't expect to see that that's going to take 6 months of beta. I'm telling you right now, it's tricky. You got to get it right. TSS took, I don't know, 18 months of really kind of ongoing development in beta when it first came out. So same process. So that's what's new. That's what's coming. There's all kinds of other, stuff. Kevin's always cooking cool new things. You guys have the 336 build. It's not public. It won't be public for a little bit here. It's in the link I sent you. Just grab that, and you'll already have a lot, some of the new things Kevin's showing here, and the ability to make building charts and reports easier. Sorry, Kate. All right. Hopefully that answers everybody's questions. And by the way, hint, the reason we scheduled the next one, look at the next webinar. It's on intervals. So it's not an accident that the timing was there and the content is vague. I will roll out to everybody on that webinar how to use optimized intervals. So if you want to see what it is, jump on it. Kyle, you get 336. It's in the link I sent you. Look in the chat box. Yeah, it's in there. So whatever your PC or Mac user, Kevin shared it with you guys, so you could use it. I mean, it's tested. It's cool. You can use it. We'll release it here probably tomorrow night or the following morning. Just let you guys test it out and play with the new chart building process.
Say we're gonna all be on the road for a few days, so we might wait till like Monday or something to put it out, just so that way we're not traveling when it goes out to everybody.
Yeah, good point.
Yeah, so you know, it's not like a super secret or something, but just so we're around to help out with tech support and stuff, or any questions that come up, we might wait till Monday. But you guys can have it. That's cool.
Cool. All right, everybody. Thank you very much for attending. I do think, look for an update. I do think, Kev, we need to do some hangouts or something like that in December. We'll talk about it over the weekend and see if we can't get, you know, a couple of sessions where people can come on and just ask their chart building questions. But, you know, we'll see.
Yeah, you know, I think it helps a lot to like take, you know, one of the charts that I built here and just sort of break it down, because once I break it down, I think then and spend the time doing that, it becomes actually a lot more simple than it looks. It's just when you see it all at once, it's really hard. So, you know, maybe if we get some feedback from people, but that might be, you know, a good learning experience. You know, is to like take a chart like this and just break it down how it works, and then how you can change it to do what you want it to do.
Yeah, actually, copy and paste is your friend. Cool.
Yeah.
All right, we're in good shape. Thanks, everybody, for your patience and being on tonight. We look forward to either seeing you at the Innovations Conference or seeing you at the next webinar, which is the week after that somewhere. Just go ahead and sign up. I know there's a lot of sign-ups now. Talk to you soon. Good night now.